Welcome back, students. Today in this session we are going to study chapter number 8, quadrilaterals. So in this chapter you are going to study what is a quadrilateral, types of quadrilateral, and some of the properties of quadrilateral as a theorem, and we are going to prove some of the theorem. So let us start this chapter by knowing what is a quadrilateral. So a quadrilateral is a polygon having 4 sides. So any polygon having 4 sides is known as quadrilateral. So a quadrilateral is a polygon having 4 sides. Here ABCD is a quadrilateral with 4 sides, that is side AB, side BC, side CD, and side AD. It also has 4 angles and 4 vertices, ABC and D. Now let us know the angle sum property of a quadrilateral. Angle sum property of a quadrilateral. It says the sum of the angles of a quadrilateral is 360 degree. That is, the sum of the 4 angles of a quadrilateral is 360 degree. Angle A plus angle B plus angle C plus angle D equal to 360 degree. So the sum of all the 4 angles of a quadrilateral is equal to 360. That is called the angle sum property of a quadrilateral. Just like the angle sum property of a triangle is 180 degree, sum of all the angles of a triangle is 180 degree, just like that. The sum of the angles of a quadrilateral is 360 degree. Now let us know about the types of quadrilaterals. First one is trapezium. So if in a quadrilateral, if the opposite sides are parallel to each other, then such type of quadrilaterals are known as trapezium. So in this quadrilateral ABCD, AB is parallel to CD. That is, the opposite sides are parallel to each other. So in a trapezium, if one pair of opposite sides are parallel, then such type of quadrilateral are known as trapezium. Next is parallelogram. If in a quadrilateral, if both pairs of the opposite sides of the quadrilateral are parallel to each other, then the quadrilateral is a parallelogram. For example, in this parallelogram PQRS, both pairs of opposite sides, this is PQ is parallel to SR and SP is parallel to RQ. So if both pairs of opposite sides of a quadrilateral are parallel to each other, then it is a parallelogram. Next, the type of quadrilateral is rectangle. So a rectangle is a special parallelogram in which its angle measures 90 degree and the angles measure 90 degree. So ABCD is a rectangle in which each angle measures 90 degree. Next type of quadrilateral is rhombus. Rhombus is also a type of parallelogram. It's also a type of parallelogram in which all four sides are equal in length. All four sides are equal. So PQRS is a rhombus in which side PQ, RQRS and PS, that is all four sides, are equal in length. So a rhombus is a parallelogram in which all four sides are equal in length. Next, the type of quadrilateral is square. So a square is a parallelogram in which all the four sides are equal and the angles measure 90 degree. So ABCD is a square in which side AB, BC, CD and AD are equal in length and its angles measure 90 degree. Next, the type of quadrilateral is kite. A kite is a quadrilateral. It is not a parallelogram, it is a quadrilateral in which two pairs of adjacent sides are equal. Two pairs of adjacent sides are equal. Let me draw a kite. So PQRS is a kite in which two pairs of adjacent sides are equal. That is, side PS is equal to side PQ and side SR is equal to side QR. So two pairs of adjacent sides are equal. Such type of quadrilateral is known as kite. Now let us study properties of a parallelogram. So it is given as theorem 8.1. It says a diagonal of a parallelogram divides it into two congruent triangles. So in any parallelogram, say suppose parallelogram ABCD, ABCD, one of its diagonals say AC, it divides the parallelogram into two congruent triangles. That is, the diagonal AC divides the parallelogram into two triangles, triangle ABC and triangle ACD, in which these two triangles are congruent to each other. Let us prove this theorem. So, proof ABCD is a parallelogram. ABCD is a parallelogram in which AC is a diagonal. In which AC is a diagonal. Now, in triangle ABC and triangle CDA. Triangle CDA. It is observed that the side BC is parallel to the side BC is parallel to AD, and in the same time AC is a transversal. So in triangle ABC and CDA, angle BCA is equal to angle DAC. Angle DAC. This is the pair of these two angles is a pair of alternate angles. These are alternate angles. Being this BC parallel to AD and AC is a transversal, so these two angles are pair of alternate angles. So in the same sense, angle BAC is equal to angle DCA. Why? Because this is also pair of alternate angles in which the side AB is parallel to CD and AC is a transversal. Now AC is equal to AC. This is common to both the triangles. So therefore by ASA congruence rule, triangle ABC is congruent to triangle CDA. So we have proved that in a parallelogram, a diagonal divides the parallelogram into two congruent triangles. Next property given is theorem 8.2. It says in a parallelogram, opposite sides are equal. So in a parallelogram ABCD, its opposite sides AB is equal to CD and BC is equal to AD. Its proof is simple. As in the earlier theorem 8.1, we have proved that the diagonal divides a parallelogram into two congruent triangles. So if AC is a diagonal, then it divides the parallelogram into two congruent triangles, that is triangle ABC is congruent to triangle CDA. Since these two triangles are congruent, side AB is equal to side CD and side BC is equal to side DA. So in a parallelogram, its two opposite sides are equal. Next, we will study some few more properties of parallelogram, which are given as theorem 8.3, 8.4, and 8.5. So in theorem 8.3, it says if its pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So for example, suppose in this parallelogram ABCD, if AB is equal to CD, and AD equal to BC, then the given quadrilateral is a parallelogram. Then in theorem 8.4, it says in a parallelogram, opposite angles are equal. So in a parallelogram, opposite angles are equal in measure. So If ABCD is a parallelogram, then angle A will be equal to angle C, angle B will be equal to angle D. Angle A equal to angle C, angle B equal to angle D. And in theorem 8.5 it says in a quadrilateral, its pair of opposite angles is equal, then it is a parallelogram. Suppose ABCD is a parallelogram and angle A equal to angle C, angle B equal to angle D. Then the given quadrilateral is a parallelogram. Next is theorem 8.6, and it says the diagonals of a parallelogram bisect each other. For example, in this figure, ABCD is a parallelogram. Then the diagonal AC and BD bisect each other. That is AO equal to OC and OB equal to OD. So in a parallelogram, the diagonals of the parallelogram bisect each other. Next, theorem 8.7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. This is the converse of theorem 8.6. So in this theorem, it says that if ABCD is a parallelogram and the diagonals bisect each other, that is AO equal to OC and BO equal to OD, then the quadrilateral ABCD is a parallelogram. The proof of this theorem is quite simple. As you can see, in triangle AOB is congruent to triangle COD. That is, these two triangles are congruent by SAS congruence rule. Side AO is equal to OC, it is given, and side OB is equal to side OD. This is also given, and the angle AOB and COD are equal to each other. They are vertically opposite angles. So by SAS congruence rule, these two triangles are congruent to each other. Since these two triangles are congruent to each other, angle ABO, therefore angle ABO is equal to angle CDO, ABO and angle CDO. These are the alternate angles for the lines AB and CD and the transversal BD. Therefore, from this we can get line AB parallel to line CD. Similarly, in the same manner, we can derive line BC is parallel to AD. Since the opposite lines of this quadrilateral are parallel to each other, this quadrilateral ABCD is a parallelogram. Hence, quadrilateral ABCD is a parallelogram because the opposite sides are parallel to each other. Hence, proof. Next, theorem 8.8. A quadrilateral is a parallelogram if a pair of opposite sides is equal and paired. Suppose ABCD is a quadrilateral in which side AB is equal to side CD and at the same time AB is equal to CD, then the given quadrilateral is a parallelogram. AB is also parallel to CD. To prove this theorem, let us draw the diagonal AC. Let us draw the diagonal AC. Then this angle will be equal to this angle because they are the alternate angles for the parallel lines AB and CD. Now, in triangle ABC and triangle CD. Triangle ABC and triangle CDA. Side AB is equal to side CD and side AC is common to both triangles, and angle BAC is equal to angle BCA. These are the alternate angles. So triangle ABC is congruent to triangle CDA by SAS congruence rule. So since these two triangles are congruent to each other, then we can say that angle DAC is equal to angle BCA. Since these two angles are equal, line BC is parallel to line AD. So line BC is parallel to AD. That is, these two opposite sides of the given quadrilateral are parallel to each other. Since the opposite sides of the quadrilateral are parallel to each other, we can say that the given quadrilateral ABCD is a parallelogram. Hence proof. Next, let us study theorem 8.9, which is also known as midpoint theorem. Let us first try to understand the statement of the theorem. Theorem 8.9 says the line segment joining the midpoints of two sides of a triangle is parallel to the third side. So if ABC is a triangle and E and F are the midpoints of the side AB and AC respectively, then the line segment EF is parallel to the third side of the triangle BC. So now let us try to prove this theorem. To prove this theorem, first we need some construction. So we draw CD parallel to AB and we produce EF to D. So we draw CD parallel to AB and produce EF to D. So now let us prove this theorem. So first we will write given information, given a triangle ABC in which E and F are the midpoints of AB and AC respectively. That is, AE equal to BE and AF equal to CF. To prove EF parallel to BC. Now construction. That is what we have constructed. Construction: CD parallel to AB is drawn and EF is produced to D. EF is produced to D. Now let us prove this theorem. Proof. Let us consider two triangles, that is triangle AEF and triangle CDF. Triangle AEF and triangle CDF. So in this two triangle, you can see that angle EAF and is equal to angle DCF. Why? Because these are the alternate angles for the line segment AB and CD and the transversal AC. These are alternate angles, and AF equal to FC. This is given information as F is the midpoint of AC. And also angle AFE, that is this one, AFE is equal to angle CFD. This is because these two are vertically opposite angles. Now, therefore, these two triangles, triangle AEF and CDF, are congruent to each other. So now, triangle AEF is congruent to triangle CDF. That is by ASA rule, congruence rule. Now, since these two triangles are congruent, we can say that EF is equal to DF, and also AE equal to CD. But also we know that AE equal to BE. That is the given information, AE equal to BE, since E is the midpoint of AB. Also AE equal to BE. So from these two, that is AE equal to CD and AE equal to BE, we can say that BE is equal to CD. Therefore, BE is equal to CD. And also we know that BE is parallel to CD. BE is parallel to CD. This is by construction. We have drawn BE. We have drawn CD parallel to BE. So BE is parallel to CD. Now, if you observe, BE is equal to CD and BE is also parallel to CD. From these two, we can conclude that the quadrilateral BCDE is a parallelogram. Since one pair of opposite sides are parallel and equal, we can say that the quadrilateral BCDE is a parallelogram. Now, since this quadrilateral BCDE is a parallelogram, we can derive ED is parallel to BC. That is, ED is EF is parallel to BC. Since quadrilateral BCDE is a parallelogram, ED is parallel to BC, that is, EF is parallel to BC. Now we have proved that the side joining the midpoints of AB and AC, that is EF, line segment EF is parallel to the third side of the triangles BC. Also from this theorem, we can prove that EF equal to half of BC. That is, the length of the EF is equal to the half of BC. Let us try to prove this. From here, we can prove that EF is equal to half of BC. EF equal to EF. Why? Because since these two triangles are equal, we have come to the conclusion that EF is equal to DF. These are the corresponding parts of the two congruent triangles. This implies EF equal to half of DE. That is, DF is half of DE. Why? Because EF is equal to DF. That means F is the midpoint of DE. So EF is equal to half of DE. Half of DE is half of BC, as DE is equal to BC, because these are the opposite sides of the parallelogram BC DE. So therefore EF is equal to half of BC. Hence proved. Next theorem. The statement says the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. So according to this statement, if ABC is a triangle and E is the midpoint of the side BE, then the line drawn passing through E parallel to BC, parallel to the side BC, then this line will bisect the third side. That is, F will be the midpoint of AC. That is, AF is equal to FC. This is line F. So according to this theorem, if a line is drawn through the midpoint of one side of a triangle parallel to another side, then that line bisects the third side. So let us try to prove this theorem. So to prove this theorem, we will construct a line CD parallel to AB. We draw a line CD, line segment CD parallel to AB. Now let us prove this theorem first. Let us write the given information. Given a triangle ABC in which E is the midpoint of AB, that is AE is equal to BE, and the line L is parallel to one side of the triangle, that is BC. To prove, we have to prove that the line L bisects the third side AC. That is, F is the midpoint of AC. F is the midpoint of AC. That is, AF equal to FC. Construction. CD parallel to AB is drawn. Now proof. From construction, we know that CD is parallel to AB, that is CD is parallel to BE by construction, and the line L is also parallel to BC, that is ED, that is ED or DE is parallel to BC. Since the two pairs of opposite sides of this quadrilateral BCDE are parallel to each other, we can say that therefore quadrilateral BCDE is a parallelogram. BCDE is a parallelogram. Therefore, BE equal to CD. Side BE is equal to CD because these two sides are the opposite sides of the parallelogram. Also, at the same time, we know that AE is equal to BE. That is, E is the midpoint of AB, so AE is equal to BE. From these two, we can say that AE is equal to CD. AE is equal to CD. Now, in triangle AEF and CDF, in triangle AEF and CDF, angle EAF is equal to angle DCF because these are alternate interior angles. And also angle AEF is equal to angle CDF. Same reason, alternate angles. And the side AE is equal to CD, which we have proved earlier. So by ASA congruence rule, triangle AEF is congruent to triangle CDF by ASA congruence rule. So now, since these two triangles are congruent to each other, we can say that the side AF is equal to FC. AF is equal to FC. That is, F is the midpoint of AC, midpoint of AC. Hence, proof.